See, mutual inductance, it's a one coil, so it's a bar magnet. So using that, you know that Faraday conduct that experiment. When that magnetic lines of force of this bar magnet is cut by this coil, EMF is induced. So the induced EMF flow in the current due to this circuit. So the galvanometer shows the deflection. So from the deflection we can find out whether it is a clockwise flow of current or anti-clockwise direction. So it's a Faraday's experiment. So from that Faraday's experiment, now we are going to see the what is mutual inductance. Self-inductance we studied about only one coil. So now we are going to see the mutual inductance. Mutual inductance means here we are going to take the two coils. When current flow through that one coil, EMF is induced in the other coil. Already we have seen that the induced EMF in the two neighboring coils. The same thing here we are going to explain the mutual inductance. So
earlier we had learned how an electric current is induced.
So see that coil, when the magnet moves towards the coil, so what will happen? So you can consider the two coils C1 and C2. One coil is connected to the battery, another coil is connected to the galvanometer. When the current is flowing through the coil C1, a magnetic flux is produced. Okay. So magnetic flux is produced here. So the next coil is far away from that, so there is no induced EMF in that coil. So now between the two coils, it is placed in a material that is it is increasing the magnetic flux. It is placed in the axis of the coil. So current flow I1 is flowing through that coil. EMF is magnetic flux is produced in the coil, primary coil. Now the secondary coil is moves towards here the primary coil. Now you can see that the secondary coil is moved towards the primary coil. It is also placed in the axis of the coil. That will be shown in the picture. There is iron rod is there. It will increase the magnetic flux. Right? So the magnetic flux is B. Induced magnetic field is B. When the secondary coil is moved towards the coil, the magnetic flux is cut by the coil, and EMF is induced in that. It will show in the deflection in the coil. So this is called the mutual inductance. When the current flow through the primary coil, an EMF is induced in the neighboring coil. That is called the mutual inductance. So ஒரு காயில்ல current flow ஆகிறதுனால அடுத்த காயில்ல current induce ஆகிறதுக்கு என்னது mutual inductance. It is far away from that coil. That EMF is there is no EMF is produced in that coil, right? So this is called mutual inductance. So now we are going to calculate that what is the mutual inductance. The magnetic flux produced by the coil, primary coil, is directly proportional to the flow of current I, right? So the magnetic flux pi V produced in the primary coil is directly proportional to the flow of current in the coil I. So that is differentiating the coil. Rate of change of coil is directly proportional to the rate of change of flow of current di by dt. Now n number of turns in the coil. So you can multiply that number of turns n. So you can write that next equation. We multiply that n pi b is directly proportional to the flow of current I. So n pi b is called the flux linkage. So what is the amount of flux is linkage with the coil? So equating that equation, you have to multiply the constant. That constant is m. M is called the mutual inductance of the coil. So dimension formula for m. So m equal to m L square t power minus 2 a power minus 2 is the dimension formula for the mutual inductance. So the SI unit of inductance is Henry. Self-inductance and mutual inductance. Both are have the same unit Henry. So 1 Henry equal to 1 T m square by ampere. So now you can see the mutual inductance of the two coils. So you can take the two coils. The one coil is placed the axis of the another one coil. So what is the mutual inductance produced between these two coils? So now we are going to see that. So what is the mutual inductance produced by this coil? So two coils are there. That one coil radius is very greater compared to that another one. That's why that another one coil is placed inside that axis of the another one coil. So first coil you can take, there is a S1 and S2. So length of the coil is L. And see that area, that is radius R1 for the inner side coil. The number of turns is N1. and S2 is the secondary coil, R2 is the radius of the secondary coil, N2 is the number of turns plus of the second S2 secondary coil. So these are two coils. Now you can consider that the current flowing through the any one coil. You can take any one coil. So the number of turns in the first coil N1 equal to N1L, N2 equal to N2L. So now that first coil S1 is current flowing through the first coil. So what will happen? Then magnetic induction is produced. Magnetic field B is produced on axis of the coil. So in that inside that axis we are placing the coil. So magnetic flux phi 1 is produced on the coil which is placed inside the coil S1. So now we are going to calculate that magnetic flux produced by the coil N phi 1 equal to that mutual inductance, because there are the two coil M1 to I. So we can take that is equation 1. So this is for the current flow the coil S1. So M12 is the coefficient of mutual inductance due to current flow in the primary coil. That is R, that's a coil 1. You can take like that. So N1 phi 1, because that current flow in the first coil. So phi equal to B into A. That is, we know that magnetic flux produced by the coil. So phi, you can substitute that value in that equation. So phi B equal to B into A. B, you know that B equal to mu naught Ni. That is a magnetic induction produced by the coil. Here the second coil, that's why we are writing here magnetic induction produced in the second coil. B2 equal to mu naught N square, N2, N2. Sorry. So area is a pi r square, because it is a circle. You can write A or you can write pi r square. You can write any one. You can write area, simply you can write A, or you can write pi r square. Okay, so pi r square 1. Instead of A, I am writing that pi r square 1. Okay, so it's a magnetic flux produced by the coil 1. So that magnetic flux is cut by the coil, secondary coil, that is N1 equal to N1 and L is the primary coil, number of turns, total number of turns. So number of turns into length gives the total number of turns of the coil. That's why capital N indicates the total number of turns. So substituting in that value, you will get N phi 1 equal to N1L mu naught N square, N2 L2 pi R square 1. So simplify that, you can write mu naught N1 N2 pi R1 square L1 L2. L1 I2, sorry. I2 is the flow of current. So you can take that equation number 6, combine that equation 1 and 6, you can write like this. So I2 cancel each other. Finally mutual inductance you will get M12 equal to mu naught N1 N2 pi R1 square L. So this is the mutual inductance produced in the first coil. Due to first coil, that inductance is produced in the second coil. So for this calculation, edges effects were neglected. Magnetic field was considered uniform. We are considering that is a magnetic field is a uniform. So solenoids of equal length were chosen. So the two coils are as the same length. So L1, suppose L1 is very much greater than R2. R2 is very small. Now so you can calculate the mutual inductance of the secondary coil. Suppose the current flow in the secondary coil. What is the mutual inductance produced in the primary coil? Now you can see that the inside that conductor, current flow in the inside that conductor. So magnetic flux is again it is produced. So that magnetic flux is cut by the primary coil. That is coil number 1. That is S1. So current flow in the S2. So again the same calculation, because it has the same length. So again you are writing that N2 pi 2 equal to M21 I1. So that is the magnetic flux produced in the secondary coil. So EMF produced in the primary coil you have to calculate. The mutual inductance produced in the primary coil you have to calculate. So M21 is the coefficient of mutual inductance. So produced in the secondary coil. Now current is flowing in the secondary coil. Due to that mutual inductance produced in the secondary coil, primary coil. So pi B equal to, again same formula we are going to use that, again pi B equal to BA, the same step what you are doing for the primary coil. So B1 equal to mu naught N1 I1. So now we have to substitute that value in this equation. A equal to pi R1 square is there. Now we can write pi R2. This is a smaller area. So we can write that is pi R1 square or you can write A. So I think in your book it's A is there, so you can write A. So A equal to pi r square, you can write A or pi r1 square for the coil, secondary coil for primary coil S1. So now you can substitute that values in that equations to calculate the coefficient of the mutual inductance. So current flow in the secondary coil, the primary coil, this mutual inductance is produced. So the EMF is produced in the secondary coil S2 due to current flow in the primary coil S1. So now you can write the next equation, substituting that value in that equation number 8. So instead of pi b you can write BA, instead of B you can write mu naught N1A, right? So N2 pi 2 equal to M21 I1 is there. So pi 2 you can substitute the value instead of pi 2 BA, instead of B you can write mu naught Ni. So we are doing the same calculation as we did in the primary first coil. Okay, so you can get the same equation. What you have to get in that M12 equal to mu naught N1 N2 pi R1 square L. The same formula you will get when you are doing the calculation for the secondary, that when the current flows the secondary coil, the mutual inductance produced in the primary coil. So here the two solenoids are equal length, so it is producing the equal amount of magnetic flux. Suppose the size length is varying between the two coil, maybe the mutual inductance will vary, but here we are taking that two coils are in the same plane. Okay, so now it is placed in a different material, that is different permeability. So what will happen, instead of mu naught you can write mu r mu naught. Okay, so finally we will get that the same equation. See that M equal to mu naught. So already I told you that same formula you are writing that N2L instead of N. So BA is a B and this is a value, substituting this value. So when you are equating these two values, I1 cancel. So M21 equal to, you will get this value. So this value at M12 and M21 are equal. So commonly we can take M equal to mu naught mu r. Suppose it is placed in a different permeability of the medium. So mu naught mu1 N1 N2 pi R1 square L is the mutual inductance between the two coils. Okay, suppose the size of the coil will vary. So what will happen? The magnetic mutual inductance also will change. So see that if the coil is placed inside that, but the length of the secondary coil is not equal to the length of the primary coil. So again you will get the same mutual inductance because it is only inside the coil. The total flux of the coil is completely cut by the coil which is placed inside the coil. At the same time, when current flowing in the secondary coil, the produced EMF is completely cut by the primary coil. Okay, suppose it is placed inside the coil also, you will get the same mutual inductance. There is no change in the mutual inductance. So mutual inductance equal to mu naught mu r N1 N2 pi R1 square. Instead of pi R1 you can write A. So M equal to mu naught mu r N1 N2 A L is the mutual inductance. Okay, so another probability, suppose you are changing the number of turns. Okay, the column it is not the primary coil. Now secondary coil is connected to the battery and the key. So now you can move the coil towards the coil which is connected to the battery. That mutual inductance is produced. So turn is number of turn is M1. The coil C1 and C2. This for the coil is placed on the axis. So again the same formula M pi 1 equal to M I2 or d by dt of dm I2 by dt. So So according to the induced EMF of Faraday's law, E equal to minus nt by n1 I1 by dt. So you can write mutual inductance M into di2 by dt. So here that M is the mutual inductance. This is for deriving the unit of Henry. So you can write M is equal to minus E1 by di2 by dt. So unit of mutual inductance is Henry. So here that E1 equal to minus M into di2 by dt from that equation. Like that you can derive the self inductance also. So you can calculate that Henry from mutual inductance or self inductance. E1 equal to minus M into di2 by dt. So this is the equations of mutual inductance.